In this video, we'll be looking at factorization of a quadratic polynomial. What is a quadratic polynomial? A polynomial of degree 2 is called quadratic polynomial. Here we are going to look at factorization of a polynomial of the form x square plus bx plus c. But what is the general form of a quadratic polynomial? General form of a quadratic polynomial is ax square plus bx plus c. But here you see c is the constant, b is the coefficient of x and a is the coefficient of x square. Suppose if the coefficient of x square a is equal to 1, what will happen to the form? A is 1, right? 1 into x square is x square plus bx plus c. So we are going to factorize this form x square plus bx plus c. Suppose when you factorize this x square plus bx plus c and you are writing this, or you are able to write this as a product of x plus p and x plus q, which are the factors, and when you multiply this you are getting this left hand side x square plus bx plus c. This is what the meaning of factorization. Factorization is writing the given polynomial x square plus bx plus c as the product of polynomials whose degree is less than the given polynomial. What is the degree of this? 2. What is the degree of this polynomial? X power 1. Here x power 1. So we have written this polynomial as a product of two polynomials of degree each 1, which is less than the given polynomial's degree, and also none of these two factors has a factor having less than its degree. Oh, then we have factorized it. See, this is the given, this is the answer. So in order to get the answer, if in the answer there are two numbers present, p and q, here p and q are integers, or we are also attempting to find the solution for a polynomial whose factors are in this form with p and q integers. Okay, fine. Then if you are able to write p and q in terms of c and b, then our job is done. If you know b and c, you will get p and q. That's it. Then we have factorized. In order to do that, let us multiply that. What is that? X into x, first term into first term is x square, and then x into q is qx, p into x is px, p into q is pq. Now x square plus, here in this term x is there, in this term also x is there. If you take out x, q plus p will come. Q plus p can be written as p plus q, because 4 plus 3 or 3 plus 4 both are same, plus pq. Now x square plus bx plus c can be factorized as p as the product of p x plus p and x plus q, where here if you compare this x square and here also x square, here also x, here also x, here also a constant, here also a constant. Then since left hand side is equal to right hand side, here also we have 3 terms and here also we have 3 terms, each are having the same unknown variables. Now compare the first term with first term, second term with second term. In the second term, coefficient of x on the right hand side is p plus q, on the left hand side coefficient of x is b, then b must be equal to p plus q. On the right hand side constant is pq, on the left hand side constant is c, then c must be equal to pq. Once you know like b and c, b must be equal to p plus q and c must be equal to pq, then you are done, your job is done and you can do the factorization now. Let me give an example here. Suppose you are asked to find, or you are asked to factorize x square plus 11x plus 30. Here you compare this with general form x square plus bx plus c. Here in place of b, what you are having here is, in place of b you are having 11, in place of c you are having 30, but b is p plus q, hence b is equal to p plus q, here b is equal to 11, and c is equal to pq, but pq is equal to 30. So the product of p and q, if x plus p and x plus q are factors of this polynomial, pq must be 30 and p plus q must be 11. So pq, the product of two numbers, 30. So you take 30. How many ways you can write 30 in terms of product of two numbers? 1 into 30 is 30. Then 2 into 15 is 30. Then 3 into 10 is 30. Then 6 into 5 is 30. So and so on. There are so many things. But the product should be 30. All of these products leads to 30. But when you add 30 and 1, you are getting 31. But when you add 15 and 2, you are getting 17. But when you add 10 and 3, you are still getting 13. But when you look at this 6 and 5, you are getting what? The addition is 6 plus 5 is 11 and 6 into 5 is 30. If p plus q is 11 and pq is 30, then p and q are 6 and 5. If p and q are 6 and 5, the factors are x plus 6 and x plus 5. Let us do that also by splitting the middle term. X square plus 11x plus 30. Here x square, 11x can be written as 6 plus 5x. So the factors are 6 and 5, right? Then p plus q is 6 plus 5. Then 11x can be written as 6x plus 5x. The order doesn't matter except in certain cases, plus 30. You can write it as 5x plus 6x or 6x plus 5x. Either way, it doesn't change the answer. Then x square plus 6x plus 5x plus 30 can be written as 5 into 6. Or this x square can be written as x into x. If you take out x in this, x will remain here plus 6 will be there, because from the first two terms x is a common factor. We have taken out x. Then in the first term x will remain, in the second term 6 will remain. In the same fashion, in the second two terms, if you take out 5, x will remain in that first plus 6 will remain in the second. Now in the second step, you see here the common factor between the first term and the second term is x plus 6. If you take up x plus 6 out, then x will remain there here plus 5 will remain there. Then x square plus 11x plus 30 can be written as a product of two polynomials, x plus 6 and x plus 5. These two does not have any further factors, hence we have factorized x square plus 11x plus 30. One other simple question we will go for our example 2 is factorize x square plus 9x plus 18. Then here coefficient of x is 9, but 9 is nothing but p plus q. P plus q should be 9 and p into q should be 18. So in how many ways you can write 18 so that sum of those two factors must be equal to 9? You can write 18 as 18 into 1 or 9 into 2 or 6 into 3 and so on, right? Here 18 plus 1 is 19, 9 plus 2 is 11, but look at 6 into 3 which is 9. Then x square plus 9x plus 18 can be factorized as x plus 6 into x plus 3 in one step you can write. How it is possible? By splitting the middle term. X square plus 9x can be written as, this is the correct one, right? Then 6x plus 3x plus 18x. Sorry, it is 18. Then here in this, in the first two terms, if you take up x, x will remain in the first term, 6 will remain in the second term. But 18 can be written as 3 into 6, right? If you take out 3, here x will remain plus 6 into 3 is 18. Because you have taken out 3, 6 will remain there. Now you look at the first two terms, x plus 6 is common. If you take x plus 6 is common, x will remain here plus 3 will remain there. So we have found it. So the general way is, if any polynomial is given of the form x square plus bx plus c. Any polynomial x square plus bx plus c is given, the factored polynomial will be x plus p into x plus q, and here b must be p plus q and c must be pq.